All right, so get this. We're diving into something today that's, well, it feels straight out of science fiction. We're talking digital twins,
Not just any digital twins, though.
right?
What?
Not the kind you might have heard of before.
Definitely not.
This is next level. We're talking real-time
Real
simulational.
time, yeah. And so powerful that they're catching the attention of some really big
Oh,
names.
yeah, huge companies. We're talking like Ansys,
Ansys, for sure. Siemens.
oh, and even NASA. NASA's interested.
You know NASA's on board. It's got to be pretty impressive.
Exactly. And all this is coming from NVIDIA.
NVIDIA. The graphics card people.
Yep, the ones and zeros, all those pixels.
Yeah.
But now they're making some serious waves in a whole different world.
The world of industrial design and engineering. That's right.
You got it. So their latest announcement, it's all about something called the Omniverse Blueprint.
Omniverse Blueprint.
And let me tell you, it's got everyone buzzing. So before we get ahead of ourselves and lost in all the hype, let's break it down. Back to basics.
Sounds good. Back to basics.
What exactly are these real-time digital twins?
Okay, so real-time digital twins. Think of it like this.
Yeah.
Imagine you're designing something really complex. A brand new airplane.
Whoa, okay, big project.
It's a huge project. And so expensive.
I can only imagine. All those materials.
Exactly. And the time, it takes forever. So imagine instead of building all those physical models, you could test thousands of designs virtually, but in real time.
Wait, so like you make a change in the design and you see the results instantly?
You got it. That's the power of a real-time digital twin. It's like a living, breathing simulation. It's a mirror image of its real-world counterpart. So engineers, they can experiment, they can analyze performance, all with incredible speed and accuracy.
Okay, that does sound pretty impressive. But haven't we had simulations before? I mean, what makes these digital twins so different?
It's all about the real-time part. That's the game changer.
Ah, okay, so the speed.
The speed is mind-blowing. NVIDIA claims that their Omniverse Blueprint can run simulations up to 1,200 times faster than the old ways.
Hold on. 1,200 times. You're saying we're talking about compressing, what, months of work into just hours?
That's exactly what we're talking about.
Wow. That's almost impossible to wrap my head around.
It's a huge leap forward.
So how do they do it? What's the secret? Do they have some, I don't know, some secret formula hidden away in their labs?
Well, it's not magic, but it's pretty close. There are three main pieces to this breakthrough.
Three main pieces, okay? Lay it on me.
First, you've got these things called CUDA-X libraries.
CUDA-X libraries.
It's kind of like, imagine specialized software tools. Tools that act like superchargers.
Or supercharger. For what?
For all those crazy, complex calculations that simulations need.
Ah, okay, so they're basically giving the simulations a massive boost.
Yeah, like a shot of adrenaline straight to the simulation.
Gotcha. So CUDA-X is like the engine, the thing that makes it all go super fast.
Yeah.
But what else is in this mix?
Okay, now here's where things get really, really interesting. They're bringing in the power of AI.
AI for simulations.
Yeah, they have this Modulus physics AI framework.
Modulus.
And what that means is AI is actually predicting outcomes within the simulations.
Yo, hold on. So AI is telling you what's going to happen before it even happens.
Basically. And by doing that, it makes those simulations even faster.
Wow. And more accurate too, you said.
Even more accurate.
It's like having a crystal ball that can predict the future of your design.
It kind of is. And then there's the final piece of the puzzle. It's the Omniverse APIs.
APIs. Now those are like what, universal translators for software.
That's a great way to put it. In this case, what they do is they let developers take this incredible technology and plug it right into their existing software.
So no need to reinvent the wheel.
Exactly. Which means all this amazing power, it becomes accessible to way more industries. It's not just for the big players anymore.
So smaller companies, startups, they can all get in on the action.
Precisely. They're leveling the playing field, making sure everyone has access to these tools.
That's a game changer for innovation, for sure. But let's get down to brass tacks here.
Sure, brass tacks.
How is this actually being used? Real-world examples.
Yeah.
Give me something our listeners can really grasp.
Okay, well, one of the coolest examples I've seen is the partnership between NVIDIA and Ansys.
Ansys, yeah. They're a big deal in the simulation world, right?
They're the leaders. And together, they've been able to get some incredible speed-ups using this Omniverse blueprint, especially in something called CFD simulations.
CFD simulations. Remind me, what's that stand for again?
Computational fluid dynamics. It's basically simulating how air or liquids flow around objects.
Oh, right. Like I've seen those visualizations. They show how air flows over a car in a wind tunnel.
Exactly. So they're basically doing that, but virtually now.
Yeah.
With the digital twin.
So no more physical wind tunnels.
Not necessarily, but this gives them way more flexibility and speed. And get this, they're not just simulating simple shapes. They did a test with a virtual car model made up of 2.5 billion cells.
2.5 billion. That's what, like every tiny detail of the car?
Every nook and cranny. Billions of data points, all being simulated at the same time, in real time. This huge simulation would have taken almost a month to run the old way.
A month, geez.
But with the Omniverse blueprint, just over 6 hours.
6 hours versus a month. That's incredible.
It's like hitting fast forward on the entire design process.
So engineers can tweak a design, and bam, they see the impact instantly.
Instantly. They can see how airflow changes, they can optimize for fuel efficiency, aerodynamics, all in real time.
It's like a virtual playground for engineers. I bet they're having a field day with this.
I'm sure they are. And it's not just cars. There's this company, Luminary Cloud.
Luminary Cloud?
They're using the Omniverse blueprint to create, get this, a virtual wind tunnel, but for wind turbines.
For wind turbines. So they're simulating wind flow around, what, a giant wind turbine?
It's incredibly complex.
I bet.
But that's the beauty of this technology. You can model these intricate scenarios in so much detail and at a speed we never thought possible.
Okay, I'm starting to get the bigger picture here. This is so much more than just, like, making cool simulations.
It is.
It's about solving actual problems and doing it way faster.
More efficiently, too.
And probably in a more sustainable way, right?
Exactly.
Okay, this is, wow. So where do we go from here? What other industries are going to be blown away by this technology?
Well, honestly, the possibilities, they're almost limitless. You think about healthcare.
Healthcare, okay.
Yeah. What if we could create digital twins, but of organs?
Digital twins of organs.
Or even like whole human bodies.
Whoa. Okay, now we're talking serious sci-fi stuff.
Yeah.
So you're saying doctors could use these digital twins to, like, simulate surgeries?
Exactly. They could test new treatments, see how they would affect a specific patient, all virtually.
So, like, personalized medicine, tailored to your exact digital twin.
Exactly. Doctors could run simulations, see how different treatments might play out, leading to much more effective healthcare.
Okay, that's amazing. It's like, what, having a personalized medical simulator for each patient?
That's the idea.
Wow. What about manufacturing? I feel like there's some big opportunities there.
Huge opportunities. Think about optimizing a whole production line.
A whole production line.
Yeah. Or what if you could predict equipment failures?
Before they even happen.
Exactly. Preventative maintenance. Digital twins, they could help create these smart factories that are just so efficient and sustainable.
So it's like giving manufacturers a crystal ball. They can see into the future of their operations.
That's a great way to put it. They could prevent all that costly downtime and cut back on waste, all thanks to digital twins.
I'm seeing a pattern here. It's like, take any complex system, create a digital twin, and boom, you've got all these incredible insights.
That's it. And we haven't even touched on urban planning. Imagine simulating traffic patterns in a city.
Okay, so city planners, they could use digital twins to create, what, smarter cities, more sustainable environments.
Precisely. It's like SimCity, but in the real world.
But with real impact, yeah.
And hold on, there's more. What about education? Imagine students using digital twins to run their own virtual experiments.
Virtual experiments. So instead of just reading about something in a textbook, they can actually see it, interact with it.
That's right. They could explore the human body in 3D.
Wow. That would completely change the way we learn, make it so much more hands-on, engaging.
It would bring learning to life, inspire a whole new generation of innovators.
Okay, this is mind-blowing stuff. But I have to ask, is there a downside? I mean, with any powerful technology, there's got to be some things we need to watch out for, right?
Absolutely. You're right. Digital twins, they come with responsibilities, just like any technology. We've got to make sure they're being used ethically, responsibly, especially when you're dealing with sensitive information, like, say, patient data.
Right. That's a good point. We can't just throw caution to the wind.
Yeah.
We need to make sure we're using this power for good.
Absolutely. We have to be mindful of the potential consequences, but overall, I think the potential benefits, they really do outweigh the risks.
Yeah, I think so too. I mean, the potential here is just enormous. To solve these big global challenges, transform industries, empower individuals, it's Pretty remarkable.
It is, and it all comes down to these incredible advancements we've seen in computing power and artificial intelligence. We're just getting started.
That's what's so exciting. I mean, who knows what's next? What kind of breakthroughs are right around the corner?
The pace of innovation, it's
Yeah.
just accelerating. It's a really exciting time.
So we've covered a lot of ground today. The technical side, the mind-blowing applications. But for our listeners, what does it all really mean? What's the takeaway here?
I think the key takeaway is this. We're seeing a fundamental shift in how we design things, how we engineer solutions, how we solve problems. Digital twins, they're not just a cool new gadget.
It's bigger than that.
Yeah, it's a completely new way of interacting with the world.
Breaking down the barriers between, what, the physical world and the digital world.
Exactly. We can simulate almost anything, analyze it,
Yep.
optimize it.
And it's making the impossible possible.
Well said.
But before we wrap things up, I want to leave our listeners with something to think about, a bit of a challenge. We've talked about all these industries, aerospace, automotive, energy, all being revolutionized by digital twins.
Yeah.
But what about, I don't know, what about you listening right now? How could this technology change things in your world?
That's the question, isn't it?
How could it change the way you work, the way you learn, even the way you play?
It's a big question, a really exciting one.
Yes.
Think about it, whether you're a teacher, designing these immersive virtual lessons.
Yeah.
Or you're an architect, dreaming up these amazing sustainable cities.
Oh, or even like a musician.
A musician, yeah. Using AI to create some wild new soundscapes.
It's not just for engineers anymore. Digital twins, it's like this catalyst for creativity, for innovation across all these different fields.
I think you're absolutely right.
It's like someone just handed us this blank canvas.
A blank canvas. I like that.
And they said, okay, go for it. Imagine a world without limitations.
A world where you can experiment with anything.
You can test ideas in a blink of an eye. You can bring your wildest dreams to life, well, at least virtually.
At least virtually, for now.
That's right.
So, to everyone listening out there, I think we have a challenge for you.
A challenge, okay, I like it.
How are you going to use the power of digital twins to shape the future? It's in your hands now.
That's a great challenge.
What?
We'll wait and see what you come up with. And hey, if you're feeling inspired, you want to learn even more, we'll be sure to include a link to NVIDIA's Omniverse website in the show notes.
Yeah, definitely check it out.
It's an amazing resource. Tons of information, real-world examples of this technology already making a difference.
It's pretty incredible stuff.
Well, that's it for this deep dive, everyone. Thanks for joining us on this wild ride into the world of real-time digital twins.
It's been a pleasure exploring it with you.
We hope you enjoyed it. Until next time, keep those imaginations firing.